So let's continue with the pinhole camera. Its features are: we have the object, the pinhole, and then we have the image. The image is formed on the screen. So when the object is placed in front of the pinhole, light from the object passes through the pinhole, and the image is formed on the screen. So pinhole consists of the closed box with a small pin hole on face and a screen of tracing paper on the opposite. The image is real and inverted. Each point of the image on the screen will be illuminated only by the light traveling in a straight line from a particular point. So I have already explained that. Then we also have some effects of the image formation for a pinhole camera. So if the pinhole is enlarged or big, the image becomes blurred and brighter. Being blurred is like you cannot differentiate this object, but you're seeing something, but you cannot tell what you're seeing, yet you're seeing something moving or coming closer to you, but you cannot tell whether it is a person, it is a bicycle, or that is what we are meaning by blurred image. The blurring of the image is because the large hole will be the same as a number of pinholes put together, each forming their own image, and overlap of this image causes a single blurred image. So that means that this large hole will cause formation of multiple images, which will make it difficult for the observer to differentiate between them. Note, the box is blackened inside to prevent reflection inside a camera. The image comes brighter because of increased quantity of light. So there is too much light which is entering. We have another effect, which is moving the object closer to the pinhole. When you move the object closer to the pinhole, the size of the image increases, but the image becomes less bright. The image becomes less bright as its size increases because the same amount of light as before spreads over a large area of the screen. So that's all about the pinhole camera. I welcome more questions in case there is any. Then we have magnification. In biology, I looked at magnification, I think so. And then as far as physics is concerned, magnification can be defined as the ratio of image height to object height, or the ratio of image distance to object distance. Mathematically, magnification, capital M, equals image distance represented by capital V divided by object distance represented by capital U. Or magnification M can be got from image height, small h, divided by object height, capital H. Large magnification is obtained when the object is nearer the pinhole, and smaller magnification is produced when the object is farther away. So we can look at some calculations here on magnification. So before you think of calculating magnification, you have to look at what they've given you. You must be having the image height, the object height, or the image distance, the object distance, in order to calculate magnification. Sometimes they can give you the three and then you're told to calculate the other one. For example, calculate the height of a building. In this case, the building is the object. Calculate the height of a building 150 meters away from a pinhole camera, which produces an image 5 centimeters high. So the image, they have given us the height of the image. If the distance between the pinhole camera and the screen is 10 centimeters. So since the image is formed on the screen, therefore the distance between the pinhole camera and the screen becomes the image distance. So when you're calculating when you're carrying out any calculations in physics, you first of all state what they have given you. So they have given us the object distance, which is, it is 150 centimeters. You have to correct that. In the question they are saying 150 meters, so you correct to 150 centimeters. So if there were meters, you had to convert all the other to 1 unit. But since they have corrected here, so you change the 150 from meters to centimeters. Then the image height is 5 centimeters, and then the object distance is 10 centimeters. So from the definition of magnification, which is image height over object height, and that very magnification is equal to image distance over object distance. Therefore, h over small h over capital H equals to capital V over capital U. So you substitute 5 divided by h, because we are looking for the image height, equals to 10 over 150. Then you cross multiply and get h as 75 centimeters. So that is it, and that is how we can calculate. Or alternatively, since they have given us the object distance and the image distance, you can first of all calculate the magnification using those two, and you see in here they got 1 out of 15. Then after, you also look at the other one of the image height over object height, and then you put the value of magnification that you got in the first one, then you substitute and cross multiply. You get your h as 75. So it's as simple as that. You can try out these other calculations, and then there are other unable questions that are following there. Then I welcome any question. Thank you for listening. Next time when we meet, we shall look at reflection of light.